Okay, class, this is section 9.2. We're going to be estimating a population mean. Last section we did estimated a population proportion. This time we're estimating population mean. Not so great because we have to use a different table. So we are so used to using the Z table, and this section uses another table, unfortunately. So we will get to that in a second, but let's just go through this first problem, this first little example here. We're finding a point estimate just like we did when we did proportions. What a point estimate does is it takes a sample and it estimates from that sample, it estimates the population number. So a point estimate when you're dealing with means looks like this. It's just called X bar. So here's our first problem. It says listed below are the brain volumes of all these people and how big their brains are. So estimate the population mean. Well, we're going to estimate it because we don't have the whole population. We just have this sample. So you can put this in your calculator and find the mean, or you can just do it old-fashioned way. Just add all the numbers up. I'm not going to write them all, but add all those numbers up and divide by, I think there's 10 of them, so 10. So when you add them all up, you're going to get 11302 divided by 10. So that is going to give us 1130.2. Okay, so from this sample, that is the mean, the average of the sample. Okay, so the point estimate for the population is that number, 1130.2. Okay, but how good is this estimate? Well, we don't know because, if we take another sample of 10, our average might be completely different. It might be similar, but it also might not be similar at all. So, oops. So, just like we did in the proportion estimate, every sample we're going to take is going to give us a little bit different thing. So, how can we be sure that the population number is anywhere close to this? Well, that's how confident can we be? That's why we have to do another confidence interval. Okay, so here's the formula for confidence interval. It is the mean that we got from our sample, plus or minus, here comes that t, this is not a z anymore. We'll talk all about that in a sec. Times the standard deviation divided by the square root of n. So there's our formula. It is in our formula sheet. Let me go over there and show you. Let's see where that is, up here in chapter 9. So there's the formula for the P, last section. Here is the one for the average. Notice it has a T, so you don't have to remember that at all. So there you go. If you look at your formula chart or your formula sheet, it will tell you when to use the T. And this is the only time we ever use the T anyways. Okay, so now back to our formulas. There's some guy named Student. Actually, his name is not really Student. This is his pseudonym. But he came up with this T. And the reason why he came up with this T is he's working for some brewery. I think it's Guinness. It's in your book. But he kept on using the Z to get a confidence interval, and he then found out, once he got the population, that once he knew the population number, that his confidence intervals were not, the population number kept on not being in there. So he wasn't very confident. So he actually came up with a whole brand new chart. That's what the T is. T works better when you have very small sample sizes. Your book always uses the T when you're dealing with means, no matter what the sample size is. So if we're doing mean, that's the formula that's in the formula chart, and so we're just going to use T. Okay, so let's go to the next page. Properties of the T distribution are exactly like the Z. It's bell-shaped with the middle, all that good stuff. And also notice this tells you right here, if you have a small sample size versus a bigger sample size, they start getting closer and closer to the normal, to the Z. So that's the bigger you get, the more it mimics the Z chart. But so just FYI. Okay, so now let's go down here, and we got to figure out how to read this guy, because unfortunately it is completely backwards from the Z table. First of all, we're gonna there's our T, just like we found a Z. So this is our little boundary. We can turn that into a T value, but the Z chart read to the left, T chart reads to the right. I don't know why they did it, but that's what they did. So unfortunately, we have to just remember that. And you don't actually do have to remember it, because it is on the picture when you go to your T. Okay, so there's your Z chart. The next page is your T, and it shows you right here that what you're finding is the area to the right. First of all, the T works off of the degrees of freedom. Does anyone remember what the degrees of freedom is? It's just degrees of freedom is n minus 1. It's 1 less than the sample size. Okay, so you have to know the degrees of freedom. Those are the numbers down the side. And in this case, this is another thing that is completely backwards. These are your areas. These top numbers right here are your areas. And notice you don't have very many. In the Z chart, the inside of the chart was all of your areas. So we don't have nearly as many areas. And then the other different thing is all these numbers right here are your T values. So it's totally backwards from the Z chart. So in order to read the T, you have to do degrees of freedom, and you have to know the area, and then you can get your T. So these values in here are the T's. Okay, so let's go back to our problem and figure out how to read this thing. So it says find the T value, so that means we're going to be looking inside the table, because that's where the T values are in the T chart. Find the T value such that the area under the curve to the right is 0.2. So I like to draw my picture just the same. To the right is 0.2. So basically this is what they're giving us. This area right here is 0.2. We have to find the degrees, the T chart, the T value. So first thing I need to know is I need to know the degrees of freedom, and it's given it to me already. Be careful, because sometimes it gives you N and sometimes it gives you degrees of freedom. So degrees of freedom is 10. I don't have to do any subtracting of 1. Area to the right, we already drew the picture, but it's 0.20. Okay, so let's go over to our chart and see what that is going to be. So here is 0.20 right here. Go down to degrees of freedom is 10. So it is, my T is 0.879. So 0.879. Okay, so all that means is it still sets up exactly. This would be just inside the first standard deviation, just like on a Z chart. So that's it. All right, so now let's go to the next problem. it says to find the t-value. Again, we're going to be finding the t-value that corresponds to a 98% confidence. Okay, so we got to remember what confidence means. Confidence means the middle. So let's draw our picture. I'm all about the picture. So this is 98%, which means what? It means I have 2% left over, and I got to share it between the tails. So 2% chopped in half is 1%, so 0.01. 0.01. Okay, remember these t's are going to be the same, just one's negative, one's positive. I'm going to work off of this one because remember the t-chart reads off of the left. Off of the right. So this is what we have. Okay, so what do we need to read? We need to have degrees of freedom, which they have given us. Degrees of freedom is 16, and it's cutting off 0.01, so to the right. So I'm going to go over here. Here is my 0.01. Go down to 16. Where is it? There it is. 2.583. Okay. So my t is 2.583. And I actually do have another t because remember confidence always has two boundary. So this one's negative 2.583. Once again, MyLabs only makes you put the positive one, which drives me bananas. But your real answer is positive and negative 2.583. Okay, so let's talk about the formula now. Here is the formula. Straight out of the formula chart, formula page. It is the mean of the sample plus or minus that t-value, so we have just started reading that, times standard deviation of the sample divided by the square root of n. Okay, this part right here, just like in the other formula, just like in the proportion formula, this part past the plus and minus is called your margin of error. So within, two, average points, or within 5 points, or whatever it's going to say. So, so that is the margin of error, the plus minus part. All right, so let's go to the next page. This is the same problem that we did at the very beginning. It's the brain volumes. Okay, so here's our brain volumes. There are 10 in our sample, which means degrees of freedom is going to be 10 minus 1, which is going to be 9. So be careful right there. A lot of people put the wrong number. So our point estimate, remember we already found this on the first page, but now we also have to get the standard deviation. So put those in your calculator just like we have always done with a 1-var, and hit 1-var on your calculator, and it'll, if you can't remember that, go back to the how to use your calculator to put data in it. Okay, so remember this one was 1130.2, and the S, be careful, it is the sample, is going to be 117.45-ish. Okay, definitely would do it in your calculator. Okay, so said here's the brain volumes. Assume a normal distribution, so that means we get to use the T or the Z. Find a 95% confidence interval. Okay, so I'm going to, if it says confidence interval anytime, I'm going to run to my formula and see what I need. So let's go up. I already know what I need, but this is the way I walk through these problems. Confidence interval about a mean is this one. So that's the first thing I'm going to do, is I'm going to write that down so I can see what I need. X bar plus or minus T. There's the T that I don't have yet. S over square root of n. Okay, I have the X bar, so that's a good That's supposed to be a check. I have the S, just got from the calculator, and I have the N. So I have all these pieces, I just don't have the T. So how do you get your T is you have to see what their confidence interval is first and put it on your picture. So there's a 95% confidence interval, which means the middle. Confidence interval means middle, 95. So that means I've got 5% left over, so that means I have to split it into 2 of the tails. So I'm going to get 2.5% over here, 0.025. 0.025, and now I can find my T value. Okay, so go to your, so what I always work on the right one because the T reads on the right. So go to your chart. Let's go down to the chart. There's my Z, there's my T. So it's going to be 0.025, and we're going to go down to 9 degrees of freedom. So that's going to be, there it is, 2.262. So 2.262. And so remember, there's another one that's negative. So our critical T value is positive and negative 2.262. Okay, so now I have all the pieces and I can get my confidence interval. So my mean from the sample is 1130.2 plus or minus 2.262. Standard deviation is 117.45. This is also where you probably need to use a bigger decimal for MyLabs. Okay, square root of, and this is in, it's not degrees of freedom here, so this is 10, so be careful right there. People get in and degrees of freedom really mixed up a lot. Okay, so this is 1130.2 plus or minus, when I cranked all that out, I got 84.01. Okay, so just like we did in proportion, you take the 1130.2 number plus 84.01, and then that same number minus 84.01. And when you do that, the bottom number is going to be 1046.19. Your top number is going to be 1214.21. Okay, so what this means is from our sample that we did, we are 95% confident that the population mean is going to be somewhere in between these two guys. So about 1046 to 1214. Yes, I rounded. So here you go. All right, now just like we did in the proportion, we can go backwards and find the N that we need, the sample size that we need in order to be 95% confident or 90% confident or whatever confidence we want. Okay, problem with this is, notice, it has gone back to using the Z. Here's the reason. If we are looking for N, we cannot use the T-chart, because remember what the T-chart uses? The T-chart uses degrees of freedom to read it. And what does degrees of freedom mean? It means N minus 1, which, well, if we don't know our N, we don't know our degrees of freedom either. So we can't use the T. So we have to go back and use the Z, which is okay because it's in your formula chart. I will show you in Chapter 9, under confidence intervals, sample size. Okay, that's what we're looking for, the sample size. When you're doing a mean, here is the formula, and it gives you that Z. It tells you that you have to go resort back to the Z. So there is the formula that we're going to use for when we're doing means. All right, so back to here. So let's do this first problem. It says you want to estimate the mean number of friends for all users on social networking website. Assuming that your standard deviation is this, so they're just handing that to us. Thank you. How many users must be included in the sample? So that means how many do we need to survey? If you want to be 95% confident, well, that word confident means I'm going to run to my confidence interval section. And so, just like we saw, here's confidence intervals. I'm not looking for the confidence interval, I'm looking for the sample size, and I'm doing a mean, so this is where it's going to steer me. Okay, so I go back to my formula, I go back to my page and write that formula. That is the first thing I'm going to do. N equals, big parentheses, Z times S divided by the E, we got to talk about that, all squared. Okay, so another thing that I like to do first is I like to draw my picture. I know I'm going to need a picture of the Z chart. This is a 95% confidence. So there's 95% in the middle. That means I got 5% left over, which means I've got 0.025 over here, 0.025 over there, and this is our Z. Remember, we're back on Z. And because we have the Z, because we're using the Z, we get to use our cheat sheet. Remember at the bottom of the Z there's a cheat sheet. So 95% confidence means the boundaries are 1.96. So these are going to be positive, oops, it's supposed to be a 9. Okay, and then negative 1.96. Okay, so I think we've got everything. We still haven't talked about that E, but we'll talk about it in a sec. Okay, so I'm going to start plugging in. This is 1.96 times the standard deviation that they are giving us. They're always going to give that to you, FYI. Divided by the E, which is the plus or minus part. So we need to keep on reading. See what it says. How many users must be included if you want to be 95% confident that the sample mean is within 10 users? So plus or minus 10. This is my margin of error. And this is not in percentage. This doesn't say 10%. It just says 10. So we just put 10. We don't change that to a percentage. And then square. And so what are we going to get is 96.8. We need to survey 96.8 people, but you can't do that, so you have to round up. So we have to survey 97 people. Ta-da! That's it. All right. Adios.